Ignition sequence start.
Good morning. Welcome to Mission Control Houston and the International Space Station Flight Control Room. The men and women you see at the consoles this morning are monitoring systems on the station and working with the Expedition 62 crew members on the last few tasks of their work week on orbit. Commander Oleg Skripochka and flight engineers Drew Morgan and Jessica Meir are in the last few hours of that workday and looking forward to a couple of days off duty this weekend as they're another busy week of supporting science experiments, taking care of their spaceship, and welcoming the arrival of a new shipment of supplies.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Isidro Reyna. This week, new supplies and experiments are now on station. A Northrop Grumman Cygnus resupply spacecraft made its way to the International Space Station with more than 7,500 pounds of science investigations and cargo after launching on Saturday, February 15th from NASA's Wallops Flight Facility in Virginia. Expedition 62 astronaut Andrew Morgan of NASA used the station's robotic arm to capture Cygnus with the help of NASA's Jessica Meir. Cygnus brings dozens of new investigations to the station. The Mobile Space Lab, the tissue and cell culturing facility, will offer investigators a quick turnaround platform to perform sophisticated microgravity biology experiments. Another investigation will provide an initial demonstration of a new miniature scanning electron microscope. And the osteomics experiment will investigate bone loss by examining osteoblasts, or cells in the body that form bone, and osteoclasts, which dissolve bone. Learn more about these experiments at nasa.gov. The SpaceX Crew Dragon spacecraft has arrived at the launch site in Florida for its first crew launch. NASA and SpaceX are preparing for the company's first flight test with astronauts to the International Space Station as part of the agency's commercial crew program. The SpaceX Crew Dragon will launch atop a Falcon 9 rocket with NASA astronauts Bob Behnken and Doug Hurley from historic Launch Complex 39A at NASA's Kennedy Space Center. The spacecraft is undergoing final testing and pre-launch processing at the nearby Cape Canaveral Air Force Station. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
More station science. You know, microbes live everywhere, and so scientists at NASA's Johnson Space Center constantly monitor the bacteria and fungi on the International Space Station. Well, now they're using DNA sequencing to identify the microbes in orbit without having to return samples to Earth for testing. That's an important step to keep crews and the places they visit safe on future deep space missions. For future missions, like sending astronauts back to the moon by 2024 and then out into the solar system, biomining could offer a way to obtain needed materials on other planetary bodies. But microbes and rocks interact differently outside of Earth's gravity than they do inside, and that might affect the output from extraterrestrial biomining. So, there's a new investigation on the International Space Station studying how microbes grow on and how they alter planetary rocks in microgravity and simulated Martian gravity.
The International Space Station will soon host some of the smallest miners in the universe, microbes. Microbes growing on the surface of rocks can gradually break them down and extract useful minerals and metals. This is a process called biomining. As we explore space, we are seeking to use biomining to turn rock and regolith into soil for growing plants and food. But before we can use this technique in planetary settlements, we first need to test it in space. On the space station, bioreactors will be placed inside a centrifuge where microbes will grow on rocks in microgravity and simulated Martian gravity. Investigators will examine how 3 types of microbes behave within pieces of basalt and evaluate how well the different microbes extract elements from the rocks. The findings will be compared to ground-based results. We hope to gain insights into how microbes interact with rocks in microgravity and how we might use them in our exploration of deep space.
This past November, we kicked off the 20th year of continuous human presence aboard the International Space Station, which so far has hosted 239 different persons and more than 2,700 science experiments. In 2019, research ranged from growing leafy greens to analyzing mining microbes and testing out autonomous robots. The research is benefiting people on Earth and helping prepare us to go forward to the moon in 2024 and then on to Mars. International Space Station crew members who support the research mission on the station get a good bit of their training on the science payloads here at the Johnson Space Center in Houston. Today, in the next episode of the new NASA Explorers series, we go to class with NASA astronauts as they train for a trip to the station.
Hi, I'm Terry Virts, and I want to talk about floating in space. One of the first things that you need to realize when you get into space is that even though you feel like you're falling, you're not. You can let go and you float. It's not a problem. It's something you really have to train your brain to think about. Another thing that you need to learn when you first get into space is how little force is required to move you. And another cool thing is you could be on the ceiling. It makes it very easy when you're working. You have to get some work done up here. You just go up on the ceiling and get your work done.
Our team of scientists is busy getting their experiment ready for launch. At the same time, NASA is preparing the space scientists who will operate the experiment aboard the International Space Station.
So as astronauts on board the space station, we are the hands and eyes of the researcher. They are telling us how best to do the science, but it's up to us to make sure that science runs correctly.
Astronauts train all over the world, including at NASA's Johnson Space Center in Houston, Texas. Here, they learn not just how to live in space, but also how to conduct science in microgravity.
So many folks ask, how much training did you do before launching to the space station? And the answer is many years. So we train in a lot of big areas. Number one is systems on board the ISS, robotics, how to do spacewalks, and actually science itself. Now, we don't learn about a lot of the science experiments we're doing until we get up there, but what they are teaching us is scientific techniques.
The techniques astronauts learn range from using tools like pipettes and microscopes in microgravity to operating scientific hardware aboard the space station. For example, we study combustion aboard the station because it behaves differently in microgravity. You wouldn't want fire to get free inside your home in space, though, so we've created special facilities to contain it. If it looks complicated, it's because it is. And it's just one of the pieces of equipment astronauts must master before they go to the space station.
Hi, I'm Tracy Neff, and this is Sharon Ranke, and we're in PDL2 right now, and we're down here at JSC to do the fluids and combustion facility training for the combustion integrated rack and the fluids integrated rack.
So basically, PDL2 is a mock-up of the US lab. Since 2008, we've been coming down and training all of the crew members who will do payloads on the space station. We've been training cosmonauts as well.
How many crew do you think you've trained at this point?
Probably 50, probably over 50 crew members we've trained.
Today, Tracy and Sharon are back at work with a former student, NASA astronaut Mike Fink. This isn't Mike's first rodeo with the station, or this equipment for that matter.
So back in 2008 and 2009, we were aboard the International Space Station when a space shuttle, STS-126, Chris Ferguson and crew, dropped off a whole big bunch of packages. And we carefully and slowly put it all together. But when it was all done, we had a brand new, ready, fresh out of the box combustion integration rack. And since then, our friends at Glenn Research Center here at NASA, we've been able to get some fantastic science about how things burn in space. Without gravity, without convection, things burn. And by understanding that better, we were able to make more fuel-efficient engines and things here on planet Earth, helping save our energy.
So you can see it in the video, all the hoses are within the ring, and so they all fit in nicely, so they shouldn't interfere with us.
Sounds great and looks great. Thank you.
So a lot had changed in 11 years since he was up there. So he did get most of the information again, and it was a new experiment, so he hadn't seen that either. He did great. He's a quick learner. It's great to work with, very methodical, and good humor, which is always, we like to have fun when we're training.
But the lab camera will be showing,
we have
and
the camera.
I will be like looking, and I'm gonna go slowly, and that would be your chance to say no.
Yes,
Through
we are watching you,
big
yes, and help you whenever we can.
This isn't the last time Tracy and Sharon will work with Mike. When he launches to the station and works on combustion projects in space, they'll watch over his shoulder through a camera broadcasting to Glenn Research Center in Cleveland, Ohio.
Christina, this is Sharon with an answer to your question. So they do want you to go ahead and install the cable tie. Copy all. Thanks for having that down for me. Anytime.
Being able to operate and maintain the space station while conducting crucial research could get overwhelming. Luckily, astronauts have strong support teams on the ground and often develop personal connections to the research.
I was so impressed at the different things we'd be working on, cancer or Parkinson's or even Alzheimer's disease. So as a physician, these meant a lot to me. These personally were very important experiments that we needed to do. But in all honesty, the entire crew, not just myself as the physician, were excited about working on these experiments. You get a little nervous at first as you begin to pipette or even utilize a microscope, which I hadn't used in years. But you quickly learn because you realize how important it is to the science, and the investigators and scientists running you through all these experiments were fantastic and just walked us through every step of the way.
Yeah, just keep us posted, but Drew and I are ready to continue up. Good working with you guys today, and I'll see you soon.
We got here on a Thursday, and it's currently Sunday. We put in a big day yesterday filling up these wells with gel solution and getting ready for handover at 7:30 a.m. on Monday, ahead of launch on Tuesday afternoon.
As part of NASA's effort to return astronauts to the moon by 2024, scientists are excited about being able to use the water that already exists on the moon to support the sustainable program of exploration. The presence of water on the moon is a relatively recent discovery, and one that opens up exciting possibilities for the future while sparking some questions about where that water came from.
Exploring the presence of water on the moon. I'm Jim Green, NASA's chief scientist, and this is Science at NASA.
We are going to the moon.
As NASA prepares to return to the moon, one of the many exciting opportunities scientists are preparing for is the ability to use the water that exists there to support human exploration. The presence of water has been a relatively recent discovery, opening up many exciting possibilities for future exploration and just as many questions about the water's origins. In the late 1990s, NASA's Lunar Prospector mission found extra hydrogen at the poles. And where there's hydrogen, there might be water. Enter the LCROSS mission, designed to determine the type and amount of hydrogen that might be present just below the moon's polar regions. Tony Colopri is a planetary scientist at NASA's Ames Research Center and was the principal investigator for the LCROSS mission.
To determine the form of hydrogen at the poles, we needed a way to access material below the moon's surface. So we carried a piece of the Atlas rocket we launched on all the way to the moon and directed it into one of the large, permanently shadowed craters near the South Pole, which caused a plume of dust and debris to shoot upwards. We had a probe with 9 different measuring instruments following the plume's 10-mile or 16-kilometer upward trajectory. The Lunar Reconnaissance Orbiter spacecraft was also making observations of the plume while mapping the lunar surface from its orbit around the moon. The lunar dirt in the plume hadn't seen the sun in over 2 billion years. In the sunlight, among other metals and gases, we found water, about 5% by weight.
Now we know there's water on the moon.
Research scientist Jen Hellman is also at Ames. She explains why the discovery is much more than just a scientific curiosity.
Ultimately, I believe we'll be living on the moon for extended periods of time, so we need to take advantage of whatever resources we can find there. Water is H2O, a combination of hydrogen and oxygen, and we can break it apart. So now we have a source of hydrogen and oxygen that may be able to be used for rocket fuel, as well as a source of oxygen for breathing. Water on the moon gives you a new paradigm for future space exploration. Very exciting.
In the 10 years since the LCROSS mission, we have continued to study water at the lunar poles from orbit with instruments on several missions. But we still have lots of questions, Where, for instance, did the water come from? Some believe that the water in other volatiles could be remnants of comets and asteroid impacts over billions of years. Others point to recent meteoric showers that can be seen producing water vapor. And where exactly is the water? We've confirmed that water exists in the Cabeus crater near the Moon's south pole, where the L-Cross impact occurred. But how plentiful is it? And can we expect to find it in other super cold regions?
We won't be able to answer any of these questions with certainty until we visit the South Pole with robots and astronauts.
Through the Artemis program, NASA is planning to do just that. Thirsting for more information about the changing science of the Moon? Visit science.nasa.gov.
The International Space Station provides a working laboratory for astronauts in microgravity, and solar energy is the key element to keeping it all running. Astronauts rely on this renewable energy source to power the machines they need for their science work, and to power the ones they need for their survival. In this demonstration video, astronaut Ricky Arnold explains the process of generating power from the station's solar arrays to produce electricity for astronauts as they orbit 250 miles above the Earth's surface.
Hi, welcome aboard the International Space Station. I'm astronaut Ricky Arnold, and I'm currently at one of our human research facilities on ISS, where you can see centrifuges, laptops, and other scientific equipment. Across from me is another one of these experiment racks, where you can see ultrasound imaging, more laptops, cameras, other equipment, all stuff that requires electrical power. In fact, we have so much equipment for science and life support that our electrical system has about 8 miles or 13 kilometers of wiring to make it all work. So where does this energy come from? Let's have a look. From here in the cupola and through other windows, you can easily see the solar arrays soaking in the sunlight. They are massive. These 4 solar arrays are made of solar cells, which are purified chunks of the element silicon. Together, the solar arrays contain a total of 262,400 solar cells and cover an area of about 27,000 square feet, more than half the area of a football field. That's huge. When the station is in sunlight, the solar arrays produce about 60% more power than we actually need during the daytime. That extra power goes directly to charging our lithium-ion batteries. Now, those batteries are essential because they provide the power we need during the 16 night times we have per day here on the space station. The energy our solar arrays can produce is enough to power 40 homes, and we can maximize the power we generate by rotating the arrays in 2 axes, one like a windmill to track the sun through the course of the day, the other to track the sun's inclination, or its angle in the sky. The space station's electrical power system uses direct current to provide energy for our laptops, lights, water recovery system, and science experiments. Thanks for coming aboard today. Now back to Earth.
Many NASA astronauts who've spent an extended period of time off the planet, such as Ricky Arnold has, return to Earth with a new appreciation for the planet that they left behind. It's also true for astronauts whose trip to Earth orbit may have been on a space shuttle mission and only lasted for a week or two. Former NASA astronaut Bill MacArthur, who has made both kinds of trips, definitely experienced a shift in his worldview after seeing the world from that distance.
When you first get to orbit,
course, main engine cuts off, and it's really funny. It's really not funny, but it's fun to watch everyone. I think everyone takes whatever writing utensil he or she has and releases it, because it's I want to see something float. Yeah, I know I feel floaty, but now I want to see something float. And then as quickly as you can, particularly a first-time flyer, it's to the window. The first thing you're overwhelmed with is how darn beautiful it is. It's darn exciting. And so immediately you're trying to identify geographical features, identify places. You look and you see things like a massive thunderstorm, a supercumulonimbus cloud coming up, and it really does come up at you. It is that tangible nature of what you're seeing that really does take your breath away. I worried my family when I was sending them notes because I started talking about the black velvet of deep space. You look in the sky here on the Earth and it's like Milky Way or those thin clouds up there. What am I looking at? But everything is really, really vivid. And I think that's another part of the visual aspect, whether you're looking out or looking down. It's part of the same thing of taking a picture of someone. Nothing captures vivid colors and texture and subtlety like the human eye does. And when you're in space, it's the same thing. And I think that's in part why it's such a powerful personal experience. And as much as we love the pictures that we bring back, it's not the same as seeing it yourself. There's a certain serenity that comes. It's not just from what you see. It's from realizing a tremendous goal that you had. And that's something I felt right after I got on orbit the first time is, heaven forbid, I could perish now, or I can never fly again, but nothing can take this experience away. I own this experience. It is mine forever.
If you'd like to take another look at any of the stories we featured today, you can by going to YouTube or Facebook at either of these addresses, handily displayed there on the screen for you. And while you're there, though, be sure to look around. There's lots of stuff you'll find about NASA and America's human spaceflight program. And if you're going to be out on the internet anyway, you should check out Houston, We Have a Podcast. It's where we talk to folks about their work in all aspects of space exploration. We post new episodes every Friday. Today, Gary Jordan goes back in history to explore the origins of plans for a space station around Earth in a talk with International Space Station Program Communications and Education Mission Manager Gary Kittmacher. That's double the daily dose of Gary's. No extra cost. Go to nasa.gov/podcasts for today's episode. That is where you will also find all of the previous episodes and the full library of all the NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.